Welcome everyone. Thank you for joining us. My name is Eve Wellard and I will be hosting the DELABIE webinar today. Before we begin, let me explain how the tools work so that you can chat with us if you would like to. On the right of your screen, you'll see two options, chat and questions. In the chat option, you can comment freely throughout the presentation. Our DELABIE teams are behind the scenes and would love to hear from you. If you use the questions option, you can ask our technical experts questions and they will reply to you individually. At the end of the webinar, we will pick up and answer the most frequently asked questions. All of the technical data covered today will be collated and made available to you in the chat at the end of the session. So let's get started. Joining me today is our UK Sales Director, Sébastien Jeux. Hello, Sébastien.
Hello, Eve.
Welcome. In the first part of our webinar, we learned all about the advantages of cistern-less flush WCs in public places. Today, in just 30 minutes, you're going to explain how the system is actually installed. So my first question is simply, can this really be done in under 30 minutes?
Well, of course it can, no problem. The cistern-less flush WC is incredibly simple. 30 minutes will be more than enough to cover the necessary planning and calculations. Our aim today is to provide our viewers with a level of technical understanding that allows them to install the system autonomously.
Before we get to grips with the technical details, could you give us a quick recap of the subject?
Yes, of course. So we are discussing WC flush systems. Currently, there are two distinct technologies vying for the top spot. The traditional toilet that flushes from a water-filled cistern, and DELABIE's innovative solution, the WC flush system without a cistern, which is powered by system pressure. Our viewers may already know it by another name. It's called the direct flush.
Forgive me, Sébastien, you said that the two systems are competing, but it seems as if the war has already been won. Toilets that flush from a cistern are pretty much everywhere in the UK.
Well, yes, that's true. However, what we also see everywhere are leaks that waste drinking water. In offices, schools, shopping centers, hospitals, it's really shocking once you know where to look. The waste is enormous, and I can't emphasize enough that we are talking about wasted potable drinking water, a vital and precious resource.
That does seem extreme.
Well, yes, exactly. And here are some statistics. According to Thames Water, a small cistern leak causing the toilet bowl water to ripple wastes around 600 liters of water per day. 5 leaking toilets in a cinema, for example, will waste 1 million liters of water over the course of 1 year, and it's entirely avoidable. This equates to the water consumption of the entire population of Leeds in a day, for example, which is a city of nearly 800,000 inhabitants. So in a context of increasing frequent droughts, don't you think that this water could be put to better use? We are talking about hundreds of thousands and possibly even millions of leaking toilets.
Thank you so much for this insight. I would like to take the opportunity to remind our viewers that the replay of our first cistern-less flush webinar addresses the question of preserving resources in public washrooms. The link is available in the chat. Let's return to today's topic, technical know-how. What is the main difference between the installation of a toilet with a cistern and a toilet without a cistern?
Well, a toilet that flushes via a cistern is powered by gravity. Standing water is stored above a toilet in a tank, and when the user uses a flush, the water is immediately evacuated into the toilet bowl.
And how about with a cistern-less flush?
Then it's a very different system. The flush mechanism works with system pressure from the water supply. And when the user activates the flush, then the pressure from the system forces the water down to flush the toilet bowl. As a result, there is a powerful flush that is always instantly available. And this effective rinse action is an ideal solution for public places where washroom hygiene is one of the main concerns.
So does a more powerful flush that is directly connected to the main water supply mean a much larger connecting header pipe for the cistern-less flush system?
Well, it is indeed. Today's toilets with cisterns are supplied via pipework with a diameter of 15 millimeters. So extremely narrow pipework can be used due to the refilling of the system, which isn't time sensitive. This usually takes around 45 seconds. Now, if the pipe is too narrow or the pressure too low, it takes longer for the cistern to refill. Installers are often called on to fix cisterns that take too long to refill. It's a really common problem. So for a toilet flush system without a cistern, there is no refill time. But there must be enough water in the supply with sufficient pressure for a short period of time to ensure an efficient flush. This is why the supply pipe will need to be slightly larger.
That's very helpful, thank you. The issue of down supply pipes seems to be a crucial one for architects and installers.
Yes, pipe sizing is the question that tends to put specifiers off from choosing a cistern-less flush toilet system. In actual fact, this isn't an issue due to the total unsuitability of toilets with cisterns in washrooms designed for public use.
Yes, because of the leaks.
Not just that, its cisterns filled with stagnant water provide a perfect environment for bacterial development, especially in places that are often closed at weekends or during the summer holidays. So the 2024 revisions of the HSG 274 guidelines underline the need for regular water quality control and the importance of accurate monitoring for Legionella. So project owners and facility managers must actively take steps to improve the water quality. The toilet flush without a cistern is a highly efficient way to eliminate bodies of stagnant water in washrooms, which are a huge source of bacterial development. If you have ever looked inside a toilet cistern, you will be aware that there is significant fouling, which is incompatible with the standards of hygiene required in public places, let alone hospitals. It would be a real shame to forego a system that effectively reduces bacterial development just for the sake of pipe sizing, and a solution that also prevents leaks, of course.
I see.
So, in short, it's true that a cistern-less WC flush requires a slightly larger pipe, but it is still a vital addition to public washrooms. Just like heating and air conditioning systems, washroom installations in public places are very different to those in the domestic sector. This system helps to prevent bacterial development, improves hygiene, and stops leaks. So it's no longer acceptable to leave a leaking toilet flush running without repairing it due to environmental concerns, as highlighted by the European Environmental Regulation of 2020. And it will also affect EPD credits for building certifications such as BREEAM, LEED, and HQE, for example. So regulations are becoming stricter, and objectives for lowering consumption are increasingly challenging.
We're now going to do a deep dive into the technical aspects of how to easily install a cistern-less WC system. Are there any regulations relating to the installation of this system, Sebastian?
Yes, that's right, Yves. As a direct flush system is still a relatively new concept in the UK, it can be difficult to find the correct procedure for pipework sizing in relation to pressure and flow rate. So, to work out how many units can be used at the same time, the usual method is to calculate the simultaneous coefficient using a trusted source such as the CIPHE, which stands for Chartered Institute of Plumbing and Heating Engineering. The approved document G, Sanitation, Hot Water Safety and Water Efficiency, available on the website gov.uk, also contains regulations and statutory guidance applicable to washroom design and build.
Sebastian, could you explain how to follow the CIPHE method in real terms?
Yes, the important thing is knowing how to find what you are looking for. CIPHE provides useful guidance and methodology, but the data needed to complete the calculations is supplied by the manufacturer. At DELABIE, we provide extremely detailed instructions in the sanitary technical data section of our public and commercial catalog, including a simple-to-use chart for calculating simultaneous use. In order to work efficiently, DELABIE cistern-less flush systems requires a supply pipe with a diameter of 22 millimeters and a minimum of 1 bar dynamic pressure. And these requirements will dictate the necessary dimensions for the header pipes.
So, does the sizing affect the dynamic pressure?
Yes. In plumbing, there are two distinct types of pressure. The static pressure concerns steel or slow-moving water, and the dynamic pressure measures the force of rapid or turbulent water moving through the pipework. So, for an installation to work well, an architect must take both into account.
Thank you. While we are on the subject, public places tend to have multiple toilets, and there is a concern that each one will then need a very large downpipe for the flush. Is this the case?
Well, that is the perception, because the flush is very powerful, and also because cistern-less toilets on the continent traditionally had exposed pipework. The cistern-less WC has developed a reputation for massive pipes. Innovation in the field has meant that we have been able to drastically reduce the flow rate necessary to supply the flush valves. So today, DELABIE's most popular product, like the Temperflux 3, have 3/4-inch inlets, that is to say, 22 millimeters, whereas a few years ago, it would have required 1.5 inches or 32 millimeters. In addition to these technological advances, the French DTU Code of Practice provides a simultaneous coefficient of use which allows significant reduction in diameter of the upright and horizontal pipe runs.
And in layman's terms?
Well, this means that the calculations are based on the fact that it will be extremely unlikely that all of the flushes operate in the same time. Therefore, the water supply needs to feed fewer toilets than the number installed. It is a simple principle. A cistern-less flush only lasts for a few seconds and requires no refill time. This means that the likelihood of multiple toilets being flushed at exactly the same time is very low.
Right, thank you. And for cistern-fed toilets, on the other hand?
So for cistern-fed toilets, the opposite is true. As the tanks takes around 45 seconds to fill, the chances of multiple toilets refilling at the same time is very high.
I see. And how is the simultaneity worked out?
So the French DTU Code of Practice, as detailed in our public and commercial catalog, indicates that for cistern-less toilets, 3 installed flush valves should be counted as 1, as only 1 valve is likely to be flushing at any given moment. For 4 to 12 flush valves, the number is 2. From 13 to 24, it's equal to 3. Now from 24 to 40, we count 4. And for the 50 toilets, the number will be 5. So the cold water system that feeds the cistern-less WCs must have a flow rate of at least 1 liter per second for up to 4 toilets, and a flow rate of 5 liters per second for larger installations. An engineer that doesn't take simultaneity of use into account will find that the results can be unpredictable. Other countries work out the simultaneity differently and are able to reduce the dimensions of the pipework even further to supply cistern-less flush systems without compromising functionality.
Sebastian, would you like to speak a bit about flow rates for sanitary ware in general?
Yes, certainly. With DELABIE systems, you can optimize the pipework dimensions throughout. For basin controls, urinals, and showers, our flow rates are calculated to the last drop to prevent waste. This means that exceptional water savings can be achieved, and equally, pipework dimensions can be reduced. Our showers are a perfect example. Domestic showers have a flow rate between 12 and 15 liters per minute, whereas a DELABIE shower has a flow rate of 6 liters per minute. At the end of the day, the whole installation should be considered when it comes to calculating the dimensions of the pipework and not just the toilets.
So do you mean that by installing water-saving controls, the pipework sizing can be reduced?
Yes, exactly. While it is true that a direct flush requires a slightly larger header pipe, on the other hand, DELABIE taps, mixers, showers, and urinals all work with narrower supply pipes. Therefore, the final impact on the sizing of the distribution network is negligible.
Thank you for clarifying. To get back to the subject of toilets, we spoke about a flow rate of between 1 and 5 litres per second, depending on the number of units supplied by the system. How does the probable flow rate relate to the diameter of the pipe?
So, to calculate the diameter, we also need to take the water velocity into account. With the total flow rate and the water velocity, we can calculate the header pipe diameter. We recommend using the Darius abacus.
The what now?
The Darius abacus. It's a simultaneity calculation chart that combines the various elements of an installation. If two figures are known, the rest can be worked out. And in this case, we already know the flow rate and the water velocity. So by drawing a line between those data points, we can find the necessary pipe dimension and the probable loss of pressure.
To make sure that everyone is following, could we work on a specific example? If we imagine that an engineer is creating a new toilet block for a large office or factory, can we go through the steps necessary together to work out the pipe sizing?
Yes, absolutely. To make it a realistic scenario, let's add in wash basins and urinals. This office here has washroom facilities that include 6 wash basins, 5 toilets, and 4 urinals. The cold water supply to the facilities will be divided into branches, allowing us to calculate the flow rate separately. If we begin with branch AB, we have 6 wash basins. DELABIE taps are delivered preset to a flow rate of 3 liters per minute, or 0.05 liters per second. Now, by multiplying the flow rate per second by the number of wash basins, we get a result of 0.3 liters per second. Next, we have the branch BC, which refers to the urinals. DELABIE urinal systems have a flow rate of 0.15 liters per second. And here we have 4 urinal valves. So the flow rate for this branch will therefore be 0.6 liters per second. As we discussed, for toilets, the recommended flow rate is 1 liter per second. In these hypothetical facilities, there are 5 toilets, so the flow rate for the CD leg will be 5 liters per second.
If I understand correctly, we're talking about the gross flow rate here, and we haven't taken simultaneity into account yet?
Yes, that's right. First, we add together the gross flow rate of the wash basins and the urinals, meaning 0.3 liters per second plus the 0.6 liter per second. This gives us a total of 0.9 liters per second. So this flow rate will then be multiplied by the simultaneous coefficient.
And for the mathematicians among us, the formula for working out the simultaneous coefficient is now on your screens.
Yes, so in the formula that you see before you, X represents the total number of sanitary points of use. When we apply this to our example, we go from a gross flow rate of 0.9 to a revised flow rate of 0.24 liter per second. In this scenario, the gross flow rate is now 4 times lower, which is why it is so important to incorporate simultaneity at the design stage.
And how about for the toilets?
Yes, as we saw earlier, the CIPHE design guide includes a chart incorporating the base data for simultaneous demand. In our example, we have 5 toilets with a flow rate of 1 liter per second. The French DTU Code of Practice tells us that only 2 of the 5 toilets are likely to be in use at any one time. So the revised flow rate will therefore be 2 liters per second. We are now getting to the end of our calculations. Once we have the probable flow rate of our installation, we add together the design flow rates of each branch. So 0.24 liters per second for the wash basin and the urinal branch, plus 2 liters per second for the toilets. That gives us a total flow rate of 2.24 liters per second. And this is when we will refer to the Darius abacus for the required pipework dimensions.
Sebastian, could you explain how to use the Darius abacus?
Yes, of course. To use the abacus, you must draw a line between the flow rate and the velocity. In this example, our line will run from 2.24 liters per second to 2 meters per second. This would provide a recommended pipe dimension of 1.5 inches to supply the 15 sanitary points of use.
Thank you so much for this clear example, which gives us a much more detailed picture of how the calculations should be undertaken. To expand further on the key to successful direct flush installation, we turn now to our experts, Robin Swailes, Managing Director, and Peter Okros, Director of Operations at Robin Swailes Design and Development. Hello, Robin and Peter. Thank you for being with us here today to share your experience with cistern-less flush systems. Could you please introduce yourselves to our viewers?
Hi, I'm Robin Swailes. I'm the Managing Director of our design company, Robin Swailes Design and Development.
And I'm Peter Okros. I'm Director of Operations, and I'm looking after the construction projects.
Before we get into the technical aspects, could you please describe the project that we'll be discussing today?
Yeah, okay, so we are designer developers, so we design in-house, so design is important to us. We've built many different things, new apartments, housing, renovations. This particular project is a life science project. We built this laboratory, which particularly fits into your products because we needed a sense of efficiency, a good standard of product, and something that looked nice.
So, Robin, toilets with cisterns are traditionally the toilets of choice in the UK. What led you to decide on a cistern-less WC system instead for the Superlab project?
Okay, it's good for us from a space-saving point of view. It's very easy to fit and it's serviceable. So a lot of people use these toilets, and with this particular system, you can service it just through one particular aperture. Everything's there. So that's really why we chose it.
And what would you say the main differences are compared to a conventional installation?
Okay, so conventional installation is time-saving. There's no moving parts for assembly. That's a big factor for us. So you don't need a lot of expertise to put things together. And the ultimate look is good too. We like the styling is good. It's kind of slightly European because it's a French company, so it gives us a little bit of edge on design.
So Peter, using grey water to flush toilets is an innovative way to preserve potable water. Was it difficult to incorporate rainwater capture into the design?
It was fairly easy to install your products with rainwater harvesting. On this laboratory build we've done, we use the whole roof area as catchment area, and then we've got a 10,000 litre storage under the car parking area, which is pumped back into the toilets. So we installed a separate pipework system to the toilets. The water coming from the roof is filtered 3 times as it's entering back into the system, and we can produce a 5-bar pressure, which is more than enough to serve these cistern-less toilet systems.
In terms of cost, cistern-less WC systems are often perceived to be comparatively expensive. Did you find this to be the case?
We didn't particularly find it was expensive. Obviously, we're building to a budget. We found, basically, compared to a high-end system, which we'd normally use, it's no more expensive.
That's good to hear. So, Robin, when you approach a new project design, which elements require particular attention?
Okay, so you can't really see the slab laboratory, but it's quite funky in its design. So we look for space, light. So everywhere in this building, wherever you stand, you can see outside. Comfort of people. So people are coming to work. It's their work environment here. So we want to feel comfortable. So, for example, there's no pillars to hide people behind. After COVID, everybody wants to sort of interact together. So we've tried to put that into the design. And we make it interesting. So we haven't necessarily used square walls. We use round walls, round windows. We've got a running track around here, for example. So interest as well, really. And they all fit into our design concept.
And Peter, are there any particular documents or software that you use to facilitate the design process?
We work in BIM. As Robin mentioned, design is very important to us. So we try to include all the elements and equipment at early stages, so we get a true reflection of what we will achieve on site. With the DELABIE products, we find it very useful, but that BIM elements are available on the website, and we can incorporate them into our drawing software. And also the specification sheets provided by DELABIE were used by our specialist designers to design the system as a whole with the rainwater harvesting.
And finally, what advice would you give to a colleague that wants to install a cistern-less flush for the first time?
I'd say definitely look at it. I'd contact DELABIE, definitely. They've got a great technical department. When Peter works on the technical side, all the measurements are there. It's very easy to see how you install it. So from the practical point of view, they're very good. We've tried to pick out certain designs that are a bit funky. So we've got some stainless steel ones and some totally black ones. So we tried to mix and match to make them exciting. Yeah, I think that's the main things with DELABIE. They're very, very good. The sales information we had was good. Someone actually called on us, which was nice. And we've had a good relationship with the company ever since.
Thank you both so much for joining us today. Your insights and expertise are very much appreciated.
Thank you.
Thank you.
And now back to you, Sebastian. Before we get to the questions from our viewers, is there any other advice that you would give to somebody who would like to install the direct flush system in the UK?
Well, first of all, I would like to thank Robin for this very good testimony. It's always a great pleasure to hear positive feedbacks like this. So now to answer to your question, Yves, yes, one very important issue in the UK market is the subject of Cat 5 air gaps and the RAS certification. So, of course, in France, the direct flush has been the system of choice for public facilities for decades, making us experts in the field. We found that in order to comply with the specificities of the UK market, we had to essentially go back to the drawing board. So we are thrilled to announce that after many years of hard work by our in-house developers and engineers, we now have the solution. Our best-selling cross-wall Temperflux 3 system, for example, now has full RAS certification and is supplied with the Cat 5 air gap. Our Tempomatic dual control flush valve is also RAS certified and fully compliant with the UK regulations. So it is worth remembering that our system can also be fed by a centralized tank, which, as we have seen with the SuperLab project, allows for the use of grey water to flush the toilets, ensuring optimal eco-credentials.
That is an important point to be aware of. Thank you. As you've overseen hundreds of cistern-less flush installations over the years, do you have any top tips?
Yes. One thing that comes up regularly when speaking with engineers and project planners is the subject of pressure loss in the connectors. The standard 22 mm pipe that we recommend has an interior diameter of 20 mm. When planning the cold water supply, it is vital to check that the internal diameter of 20 mm is maintained at the connections and throughout the distribution system to prevent pressure loss. The rare cases where we have had problems with an installation, For example, the flush that was not working as it should have almost always been due to a mistake made during installation. For example, excessively narrow pipeworks in the cold water supply or incorrectly sized connectors which didn't follow our recommendations.
So we're getting to the end of our discussion. Could you sum up the main technical information to remember?
Certainly. To complete a successful installation, there are 3 things to bear in mind. 1, cistern-less flushes require a flow rate of at least 1 liter per second. 2, there needs to be a minimum of 1 bar dynamic pressure for the flushes to work efficiently. 3, when doing the calculations, work out the growth flow rate for all points of use valves except toilets, then calculate the toilets flow rate separately before adding them together to work out the correct design flow rate.
Thank you for this excellent recap. Any other final thoughts?
My hope for today is that specifiers and installers who have followed this presentation will have a clearer understanding of the direct flush toilet without a cistern. It is a system that differs from cistern-fed toilets. However, the technology itself is very simple. Of course, toilets with cisterns do have the benefits, but they are also responsible for a vast number of leaks in buildings. And given the concerns of drinking water supply, the subject must now be broached. The problem of leaking taps has largely been solved, whereas we continue to accept leaking toilets. This signals the need for a new, more reliable solution. And the cistern-less direct flush toilet is the solution. It eliminates leaks and provides up to 90% water savings. In terms of cost, the cistern-less flush is very affordable due to the significant water savings that it generates. This means a much lower water bill. And then maintenance time is also reduced to a minimum, and there is no need to frequently change parts. So a cistern-less flush system will actually pay for itself within a few months, while a toilet with a cistern will waste increasing amounts of water and become more and more expensive over the course of its life. So the conclusion is therefore that cistern-less flush system is the best technical solution for public places. It is simple to put into place and ensures that budgets and drinking water consumption can be managed effectively.
Thank you very much, Sebastian, and to Robin and Peter for these valuable insights. Thank you also to all of our viewers today for your attention and interest in the subject, and we will see you very soon for the next DELABIE webinar.